Understand? Good. So we're going to write 1, 4 on the notes page. So here it is right here. All right, I'm going to circle. Here, I've got the answer key up. It's right here. Capiche? Now we're going to do this one right here. Negative x squared minus 6x minus 10. So, oops. So let me clear all my drawings. Let me get out of this. So the function y equals negative x squared minus 6x minus 10. I look at the picture. Oh, I see I have a maximum point. My maximum point occurs right there. I have a max. So I'm going to go second, trace. I want maximum, option 4. It's asking me left bound. Left bound. Well, left bound has to be to the left of the point. So left bound has to be somewhere over here. Right bound has to be somewhere over here. Everyone understand? So I'm going to way down there. Move my cursor to the left of the red dot. Enter. Move my cursor now to the right of the point. Enter. Guess. Enter again. My maximum occurs when x is negative 3 and my y is negative 1. Look at the answer key. Everybody see? Good. Now let's do this one. X squared plus 2x minus 1. So again, let me clear all my drawings. The equation is clear. The equation is x squared plus 2x minus 1. I look at the graph. I see there's a minimum, a lowest point. So I say, okay, well, I know the calculator is going to ask me left bound. Left of the point is somewhere over here. Right of the point is somewhere over here. Everyone understand? So to find the minimum, second, trace. Minimum, option 3. I hit 3. It asks me left bound. I move the cursor to the left of my point. Enter. Now it's asking me right bound. I move the cursor to the right of my point. Enter. Enter again. What did I say? When you get a funky decimal like this, it rounds to x equals negative 1. Everyone understand? If I had like decimals that were changing, now I know my minimum occurs at a fractional point. Everyone understand? Good. And my y value is negative 2. So if you look at the answer key, I've got negative 1, negative 2. Everybody capiche? Good. So I'm going to stop sharing my screen. Let me go over here. Oh, I don't need tablet. Please confirm. Negative 1 and 2. Everybody can see my tablet? Good. All right. I'm not going to sketch these because we just did all 3 of these. Everybody understand? The answer key will have the sketches on it. Marin, where are you? Aksa, where are you? Cameron Lewis, where are you? Move your cameras down, please. All right. So now, comparing. Comparing means you got to look at 2 different things and decide, which one is the correct answer. So it's asking me which function has the smallest minimum. Minimum. Hold on here. I just want to point something out. Let me go back over here real quick. So we know that this one had a minimum. We knew that this one had a maximum. We knew that this one has a minimum. Can somebody please tell me, we know that x squared minus 2x minus 3. That's this equation right here. This has a min. This one, right, negative x squared minus 6x minus 10 has a max. And then this one, x squared plus 2x minus 1, we said had a min. Is there a way for me to tell if my quadratic, my parabola will be a max or a min just by looking at the equation? Yeah, that's a good question. Maimuna's like, I don't know. Let me think about that one. No? Well, I guess now I do need to sketch these. All right. So let's see here. The x squared plus 2x minus 1 looked like this. Let me zoom on in. It looked like it had a minimum at -1, -2. So here's my minimum. I had a 0 somewhere here, and then I had a 0 somewhere, nope, here. So I connect my dots, and I do this. And then this one had a maximum, and it looked like this. X squared, hold on here, minus 6x minus 10. You're going to see, it's going to blow your mind. So this one had a minimum at -3, -1. There's my minimum. And x squared, oh, negative x squared. X squared. And then delete. Look at the graph. Let this person in, Alexander LeBron. So this one looked like this, and it went like that. And then this one had a minimum at 1, 4. 1, 2, 3, 4. And it looked like this, and it looked like that. Okay, now take a look. Take a look. This first graph we said had a minimum. Yeah? Minimum. Doesn't this look like a smiley face? Yes? What do you notice about the x squared term, the number in front? It's positive. If I have a smiley face, I have positive parabola. Parabola. Everybody understand? So if I have a smile, I'm going to have my chin is my lowest point. Everybody understand? Now take a look at the equation for this one. It's got a negative x squared and a max. My maximum is right here. What does that look like? That looks like a frown, does it not? Yes? So if my x squared term is negative, I will always have a maximum point. Understand? Again, look at this one right here. It's positive x squared. That means I'm going to have a positive parabola with a minimum point. Everyone understand? So now, let's compare two different parabolas. Which function has a smallest, a minimum? If it's telling me it has a minimum, that means my parabola is going to look like a smile. Everybody understand? So I look at this one and I go, all right, this is g of x. I have to determine, does g of x have the smallest minimum, or does h of x have the smallest minimum? Everyone comprende? So I can look at the graph and go, oh, well, this point is at 1, 2, and then negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. Okay. Well, h of x, I don't know what h of x looks like. I have to put h of x into the calculator. So I go to the calculator, share my screen, and then I go to y equals, clear this, and I type h of x squared plus 2x minus 6. I look at the graph. I go, oh, I can't tell what the minimum is. So I do second, trace. I know I have a minimum because I can see a lowest point, left bound. I move my cursor slightly to the left of the lowest point, enter. I move my curve slightly to the right of the minimum point, right bound. I hit enter a third time. My minimum is at x equals -1, -7. Everyone understands? So then let me go back here and then share my tablet screen, start my broadcast. Come on. Come on, tablet. All right. So I know the minimum here is -1, -7. So now, which one has the smallest minimum? Remember what we said. How do I tell high or low? Am I looking at the x-axis that goes side to side or the y-axis that goes up and down? Good job, Maimuna. I'm looking at the y. I must compare y values. So which one has the smallest minimum? So I'm looking at -10, -7. So I write -10, -7. Which one is the bigger number? -7. -10 is less than -7. So that means this is the smallest minimum. Everyone understand? So I would write g of x has the smallest minimum because -10 less than -7. Everybody understands? Good. So now I have to look at this right here. How do I figure this out? So in order to determine this, right, I have to look which one has the smallest minimum. So again, minimum means my graph looks like this, which means I have to compare y values. Everybody understand? So I look at the table first. I see -2, -2, -5, -5. And then I know this is my vertex. Everybody understand? Yes? I know my minimum point is my vertex. Everybody understand? Good. So what do I know? The minimum point for the table? Yes. For this one, for f of x, right? Minimum value is -6. Everybody comprende? Good. So now what do I do about k of x? So you ready? Stop sharing my screen. Stop. Let me go back over here. Share my calculator. Share my calculator. Everyone see my calculator? Thumbs up if you see my calculator. Good. So I go to y equals, I hit enter. I literally type parentheses, x plus 5, close parentheses, open parentheses, x plus 2, close parentheses. I look at the graph. I see, oh yeah, I got a minimum. Second, trace. I want option 3 for minimum. My cursor is way up here. Move the cursor down. Left bound. Left of the lowest point. Enter. Right bound. Move the cursor slightly to the right. Enter. Enter again. my minimum occurs at x equals negative 3.5 and y is negative 2.5. Everyone understand? Yes? All right. So let me share my screen again, my tablet. There it is. Come on, note shelf. So I know this one has a minimum when x is negative 3.5 and y is negative 2.25. So it's looking for the smallest minimum. Minimum, remember, we're looking at the y values. So then I go, all right, well, which one is smallest? Negative 6 is less than negative 2.25, making f of x having the smallest minimum. Everyone understand? So my answer would be f of x has smallest minimum because negative 6 is less than negative 2.25. Any questions with this? Good. All right. So let's see here. I think that was it. That's the last page. This is the last page of the notes, and we literally have, what, a minute left? So we're going to leave it. I'm going to post the answer key. This one is making you compare three functions. Which function has the largest maximum? Again, maximum, compare y values. Everybody understand? Don't go. Give me 3 minutes. Give me 3 minutes. So I look. P of x is up here. 1, 2, 3, 4. It looks like it's like 4.5. All right. So let's see. And then f of x. F of x is, let's see here, negative 3, 5. And then I look and I go, wait a minute, 9, 9. My vertex is in the middle. Everybody understand? Okay. And then this one, I have to put it into the graphing calculator. All right. So we are out of time. I will post the answer key for this. Everyone understand? This is not hard. You're just comparing the y values. All right. Have a good day. Your independent practice is up. Goodbye.